problem 6-3. We have a truss here. One load is 800 and the other one is 0. Now sometimes the truss, it's best to go ahead and solve for the reactions first. But in this case, I think we can start by this end and work that way. So let's start by redrawing the truss, like so. Okay, and we'll put a load here of 800. Now I'm going to go ahead and erase the center part so I have my joint diagram, or joint free body diagrams. Now if we look at this one, this joint has a horizontal and it has a diagonal. Now the diagonal will have both of a horizontal and a vertical. So we got to look at that joint. That joint has to be in equilibrium in the x and y direction. We have 800 down, so this must, since it's the only other vertical force, it must have 800 up. Now it's a 4-4, so this is a 45-degree angle, so the horizontal and the verticals are going to be the same. So this has to be 800. Now we have to have equilibrium in the x direction. So if this has 800 going into it, this must have 800 going out. And this joint is now in equilibrium. In the vertical, we have 800 down, 800 up, 800 left, 800 right. So it's in equilibrium. And we follow those forces across the member in the equal and opposite direction. So this is 800 and 800 and 800. Now, looking at this joint, there's nothing in the vertical here. So this must be a 0 force member, which makes this 800 and our x equilibrium. And this is 800. Now, here, this has a vertical, this has a vertical and a horizontal. I'm sorry, this has a horizontal, this is a vertical and horizontal. So the only vertical to counter this 800 is an 800 up. Since this is 0, you can't counter it. So this is also to 45, so if that's 800 up, this is 800 over. Now we have 800 over, so this must be 1600 to the left. And now this is in vertical equilibrium and horizontal equilibrium. So if that's 1600 that way, this is 1600 this way. Now I didn't draw in the reactions. Here we have a reaction in the x and a reaction in the y. This just has a reaction in the y. So here we go. So we'll call that Cx, Cy, and this is going to be that way. Ex. Those are 3 reactions. So it's 1600 this way, so Ex is clearly 1600. We got to carry this one through. So this one is 800 up, so it's going to be 800 down and 800 to the left. So here, we've got 800 to the left, 800 to the left, so we need to have 1600 to the right for x equilibrium. 800 down, Cy is going to have to be 800. So our reactions are 1600 in the x, 800 up, and 1600 in the y. Now we can look at those. That puts, if we look at our whole truss, ignore all the internals, right? 800 and 800, 1600, 1600, we have equilibrium on the exterior part. This says state which ones are in tension or compression. So if it's pulling in, that would be tension. Tension pulls in, compression pushes on a joint. So if it's pulling in, it's in tension. and that's pulling in. And if it's pushing out, it's in compression. And that does it.